Welcome to everyone joining us for this session. This is a Pearson Edexcel International GCSE Science, getting ready to teach International GCSE Physics. It comes in two parts. The second session is at the same time tomorrow, and over the two sessions, we look at a number of ranges. It's really aimed at people who are new to this specification. There might be a number of reasons why you're joining this session. It may be because you've recently moved to a school which is teaching this specification and it's one you haven't taught before, or your school may indeed have changed specifications recently and so you're new to it because of that, or you may yourself be new to teaching. For any of those reasons, as I say, you're very welcome joining us. My name is Keith Penn. I'm a teacher of physics. I've taught physics to A-level and GCSE and all sciences, physics, chemistry and biology, to GCSE for 33 years. And now I work as a lead trainer for sciences for Pearson Edexcel. And I'll be presenting this session and tomorrow's. I'm delighted to be joined this session by Faina, who's our moderator, who you heard a short while ago, just introducing the session. And as she said, she will be able to pick up any questions that are related to the technical aspects. If you struggle to be able to hear us, if your sound goes, for example, I know from past experience, the easiest thing is to log out and log back in again and restart your browser. If it's more technical than that, please do send a message to Faina and I'm sure she'll try to sort you out. As you mentioned, the session is recorded and you should be able to download the recording if you, for example, if you miss a session of it, or if you go down for, your internet goes down for a short period of time, you should be able to access the recording later on. A link should be sent to you within an hour or so after the end of this session. During the session, or in the training over the 2 days, we'll be looking at how the qualification is arranged, reviewing the content of the qualification and exploring how to plan the course or lessons. And then mainly in tomorrow's session, we'll be looking at understanding the assessment, looking particularly at how the questions are set and how the qualification is assessed and how to prepare students for those assessments. And over both sessions, we'll be having a little look at identifying support that's available from Pearson. So let's move on to that. I'm just noticing a question from Zivanti. It appears I'm having trouble and unable to hear the training. Will it be possible to obtain the recording? Yes, the recording, as I say, a link should be sent to you within about an hour after the end of the session, and you should be able to download the recording directly from it. The link will be sent to the email that was used for you to register on the course. So if someone else in your institution registered for you, you'll need to talk to them because that's who the link will be sent to. Okay, I'm going to turn my camera off for the moment. You don't need to see me all that time, but you should be able to see the screen saying welcome to Pearson. Okay, first of all, we're the world's leading learning company, and as the UK's largest awarding organisation, we think best placed to provide qualifications that are aligned to the British educational system. Our international heritage stretches back over 150 years. Today, we partner with schools, universities and employers worldwide, offering world-class, globally recognised qualifications to over 3.5 million students every year. We're a trusted and recognised qualifications partner to over 6,500 schools, colleges and employers globally. We mark over 10 million exam scripts on behalf of the UK Department for Education each year, and we operate in 70 countries worldwide. I'll just say at this stage, I mentioned at the beginning that this is for the International GCSE, and that's particularly popular and used worldwide in particularly international schools, but other schools too. But Pearson also offer UK qualifications, UK GCSE, and a small number of schools offer both those routes, both those specifications. As I say, mainly international schools in an international setting in countries other than the UK tend to offer the international GCSE. State schools in the United Kingdom are not able to offer the international GCSE. They're required to offer the UK GCSE. a small number of schools, particularly fee-paying schools based in the UK or fee-paying international schools, are actually allowed to offer the international specification as well. So in some cases, there are schools that offer both routes, UK and international. If you're in one of those schools, you do need to be aware that there are differences in the way the two specifications are, particularly in the way that they're assessed and the way in which questions are marked and so on. So I will draw occasionally attention to those. If you're in a school which only offers the International GCSE, not a problem for you. But as I say, if you're delivering to different groups of students, the UK GCSE, there are differences. So do be aware of that. They're not exactly the same. Specification and assessment overview, a brief overview before we look at some of the details. So this slide just outlines the main starting point, along with the getting started guide, resources for the specification and what's to be found in them. The specification is the main document that you need to teach the course. It outlines the aim of the course, as you'd expect, the content that you must cover, and all the information you need about assessing your students. A copy of this document is freely available on our website. I think the easiest thing to do if you're looking for the website is to type into Google or any other search engine the combination of the words Pearson and International GCSE, and then you can scroll alphabetically through the subjects. But I will put a link to that in the chat if I can, just to, in case you're struggling to find that. There you go, that should be, there we go. There's a link to that document. That's the specification. Since you've come on this course, you've probably already had the specification, but as I say, it's also downloadable from the resources that are with this presentation. There are also sample assessment materials. And the document that you can see on the right of the screen there provides examples of the question papers. It's especially useful when a specification is first launched. Because there are now several series of live exam papers, it's been going for several years, it's arguable that the real papers become an increasingly more important resource than the sample assessment materials. But when it's the first year of a specification, obviously, sample assessment materials are really helpful because it gives an indication of what the questions are likely to look like. We now know exactly what the questions look like, having had several years of this. So as I say, that document becomes a little less important. Using the specification, here are some key descriptors of how the specification is coded. It's essential for understanding how the specification is laid out. The content is arranged as 8 topics. As a minimum, all of the bullet points in the content must be taught. Where it says the word including in the content, that specifies the detail of what must be covered. When it says examples, throughout the content, we've included examples of what could be covered or what might support teaching and learning. And it's important in these cases to note that centres can use other examples. So there's an indication there with the word content, or the including and the examples, which things have to be covered, which students need to know and will be examined upon, and examples, ways in which it might be taught, but you could use alternative examples for those. Practical investigations we'll talk about more later, but they're included in the specification as in italics, so it highlights which are investigations. And specification statements that are in bold print with a P reference, and I'll show you what I mean by that in a moment, they relate to content that's only in the International GCSE in Physics, not the Combined Science Double Award. Obviously, alongside the international GCSEs in the separate sciences of physics and chemistry and biology, there is a combined science double award, which includes all 3 of those. And there are elements in the physics only, which don't appear in the physics element of the combined science. And those ones which appear in physics only are identified in bold in the specification. Because in some schools where you have relatively small groups, it may be that you're teaching some students who are doing the separate sciences alongside students who are doing combined science. And it's important to know which bits all students need to know and which bits need to be highlighted to the students doing the separate sciences. So looking at an example, this is a page from the content section. And I can indicate some of the features that we just mentioned in the previous slide. So for example, here, you can see that the practical investigation 6.6, here's a page on magnetism and electromagnetism. You can see point 6.6 is in italics, and that's because that's a practical investigation identified there. So all practicals are identified in italic print. And further down this page, there, you can see point 6.9 with a P, 6.10 P and 6.11 P are also printed in bold, and that identifies those points as things which need to be known by students who are doing individual separate sciences, the physics, but not to be covered by students, or don't need to be covered by students who are doing the combined double award science. Okay, and that's consistent throughout the specification, and indeed for chemistry and for biology, they all use the same pattern. We're the only exam board at the moment to offer the choice of both modular and linear routes for students taking international GCSE qualifications. If you're happy with the linear approach, there's no pressure to move to the modular route. The linear international GCSEs will continue to be offered, and I know they will be, as they are now, taken widely by students around the world. However, if you believe that the modular route will be of benefit either to your existing students or to help you attract other prospective families to your school, we can support you in moving to this route for your selection of subjects. So the modular route, unit assessments can be taken over multiple exam series. The grades are calculated on raw marks, which are then converted to a uniform mark scale, a UMS mark, and students can resit individual units in any exam series. Once a student has all the unit results that they need, they can cash in these results for a grade for the whole subject. And the linear route, which is the one that's been offered for some time now, assessments for all units are taken together in one exam series, so the traditional way really. Grades are calculated on raw marks only. Students can resit assessments for all units together in one exam series. You can't resit individual units, but you can resit the assessment for all the units. You can resit the subject, as it were. And the grade that students receive are calculated at the end of the exam series in which they sat their assessments. You don't have to cash them in. You've automatically done that by entering the final exams. The modular and linear approach contain the same content, but the modular approach breaks the journey into 2 units with an exam at the end of each unit. If you're already offering Pearson Edexcel International GCSE Linear, this will continue to be offered and remain exactly as it is. Students taking the linear approach will have studied all the content before the exam, so the linear specification is structured in a way where all topics can be assessed in both exam papers. Examinations on both routes contain a mixture of different question styles, and they include multiple choice questions, short answer questions, calculations, and extended open response questions. A calculator, says in my notes, a calculator may be used in the examinations, but as a physics teacher, I would say a calculator must be used in the examinations. Your students need to have a scientific calculator that they're familiar with using for the exams, or they will be seriously holding themselves back. So you can see on the page there the way in which the paper is outlined. In the linear paper, it's a 2-hour written exam, whereas in the modular, it's a 1 hour 40-minute written exam. It shows the number of marks there and what percentage it is of the total international GCSE. And then the content summary. You can see the 8 topics: forces and motion, electricity, waves, energy resources and energy transfer, solids, liquids and gases, magnetism and electromagnetism, radioactivity and particles, and astrophysics. In modular paper 1, you can see that it's topics 1, 2, 4 and 5 that are examined: forces and motion, electricity, energy resources and energy transfer, and solids, liquids and gases. And if we go on and look at paper 2, okay, in the linear, this is now 1 hour 15-minute written examination, about 40% of the total GCSE. It also assesses content from all 8 modules, whereas in the modular paper, 1 hour, 40-minute written exam, about 50%, half of the total GCSE, and it examines topics within topic 3, 4, 5, 6, 7, and 8. Okay. You may want to change the way you teach the International GCSE, that should say physics, specification content, if you take the modular route for assessment. To support your planning and teaching of the course, we're producing course planners, editable schemes of work, and a getting started guide. The first teaching for International GCSE Physics modular route is this September 2024. First assessment will be next summer, May, June 2025. So the modular route is new, but as I said, based on the same content as the linear route, which has been going for several years now. Just about resits for the modular route. Learners can resit any unit, irrespective of whether the qualification is to be cashed in. If a learner resits a unit more than once, only the better of the 2 most recent attempts of that unit will be available for aggregation to a qualification grade. So although students can retake it, 4, 5, 6 times, it's only the best of the 2 most recent attempts that are available. You can't just cash in the highest mark you got in the last 5 years, as it were, and top them all together. Craig's asking, is there a price difference between modular and linear? And I'm actually not absolutely sure about that. Later on in the session, I'll give you a contact detail for the science, what's the word I'm looking for? The advisor, sorry, the science advisor for the subject advisor. That's the word I was looking for. Irene. I'll give you her contact details, and she can tell you exactly the answers to that. Shaz is saying, can I have these slides? When you're sent the link within an hour or so at the end of the session, yes, you will be sent also a link where you can download the slides as a PDF form, so you'll be able to see the slides. Yeah. The check will then teach us the checking criteria and methods of doing so. When we look at assessment tomorrow, we'll be looking exactly at how the different types of questions are formulated and how they're assessed and the ways in which they're marked. So yes, I will be going through that, but that's mainly in tomorrow morning's session rather than in this morning's session. Yeah, so yes, we will be covering that. Where'd I got to? Yeah. Results of units will be held in the unit bank for as many years as the specification remains available, and a specification is usually held for at least 5 years, so there's some consistency within that. Once International GCSE has been in physics has been certificated, all the unit results are deemed to be used up at that level. They can't be used again towards a further award of the same qualification at the same level. So if you cashed in your GCSE and then you decide to retake it for some reason to up your grade, you can't reuse modules that you did particularly well in the past time. You've got to be entered for them. Will we be awarded with a certificate of participation? It's my understanding that that will automatically be sent. As I mentioned earlier in answer to an earlier question, that will be sent to the email that was used to register you on this course. So if you registered yourself, it will be sent directly to you. If someone else, your head of department or inset coordinator or someone entered you, they will get the email with the certificate of participation. If you weren't able to register tomorrow's session, I would try again. There still are vacancies for that, certainly, Christina. So I would try that again. There are still places available on tomorrow's session. I'd go back in. That might just have been a glitch on the website at the time. It will be at the same time tomorrow. Yes. Yeah. So UK time will be 9 o'clock tomorrow. Yeah. I should have said it's 9 o'clock here, but I am aware that many of you are joining the session from different parts of the world where the time may be different. So my apologies if I say later this morning and it's already afternoon where you are. That's just because I'm here just outside Cambridge in the UK, where it's a particularly wet and cold morning. I'm hoping that the weather is hopefully a bit better where you're joining the session from. Can you explain the last point of the previous slide? Let me just go back a section. Where are we? This one. Yes, sorry. If you've done the modular section, sorry, if you're doing the modular route, if a student has tackled all the modules, has done all the assessments and cashed it in other words, and a certificates have been awarded, let's say you've got a double C or something like that, or a C for the physics. All the modules that you've done up to that, the marks that you've had have been used up, as it were. If the student decides the following year to retake the exam to try and up their grade to a B or an A or whatever, sorry, I'm still talking in letters, but in the number code as well. If they want to upgrade their mark, you can't reuse marks from modules that have already been certificated. So if you've received the certificate, all the modules taken up to that date and the marks are considered to be used up. If they want to retake the exam after they've been awarded a certificate, they would have to retake all the modules again, and it's the new marks that would count towards that. You can't say, oh, I did particularly well in energy last time, can I reuse the mark from that module? No, it all comes from the next resit if you're resitting the whole thing. Can students get the exam paper 1 in May and paper 2 in November? Yes, as I say, May or June 2025 is the first time this one will be offered. But yes, you can, I believe. Will paper 2 be available by November? I believe so. Yes. That's if they've cashed in. Yes, absolutely. It is exactly like the old cashing in system. Yeah. Okay. Sorry, I just come on to this, and it's our first activity. Fairly short activity, but you need the specification for it. Should I say, you can download from the resources attached to this or from the link that I shared with you a short while ago. It's a part of a question from paper 2, and all I'm asking you is not to answer the question. You're all good teachers, I'm sure. I'm not asking you to answer the question, but what parts of the content, which specification points, in other words, are being assessed by this? So which specification points are being assessed? I should say that when examiners are writing exam papers, they don't look at any of the course books, workbooks, published resources, any other documents for asking questions. They entirely look at the specification. They're only asking questions based on the content of the specification. So if you want a definitive answer as to whether a particular part of the course is likely to be questioned, the thing to look at is the specification. They will only ask questions based on that. And so each question is based on one or more points in the specification, and all those points are numbered. Okay, so here's a question. You can see 2 students use this method to investigate sound from a moving source. Student A is holding a buzzer on a piece of string and spins round so that the buzzer moves around her in a horizontal circular path. She spins round at a slow speed, then spins round at a higher speed. Student B, over on the right there, stands several meters away from student A. The sound heard by student A is different to the sound heard by student B. Discuss the differences in the sounds heard by student A and student B. I don't want your answer to the question, but what I do want you to put into the chat, if you feel confident to do so, which specification point or points are being assessed by this question. And I'll give it a minute or two for you to flip through your specification content and tell me which specification point or points are being assessed by this question. You don't have to put all the text there, but thank you, Yasmin. Just the number would do. Ha, well spotted, Heyman. Thank you. Yes, you're absolutely right. People who've put 3.8, it's most closely related to topic 3, waves, and the specific specification point 3.8 which, as we just saw a little bit earlier, explain why there is a change in the observed frequency and wavelength of a wave when its source is moving relative to an observer, and that this is known as the Doppler effect. But you could also argue that it's related to topic 8, astrophysics, because 8.15p says describe that if a wave source is moving relative to an observer, there'll be a change in the observed frequency and wavelength. So of course Doppler effect comes up in the sound and waves idea, but also comes in the idea of Doppler redshift, and so, in space and astronomy element. And I did say on the question that the example comes from paper 2, so it means that either of those specification points could be being addressed, because 8.15 is a P, it's only for single science physics students. But remember, paper 1 only assesses those specification points not in bold. Paper 2 assesses all the content. So it could be either of those, 3.8 or 8.15. Both are possible. Well, thank you. So, what I want to ask you now is to choose one topic or part of a topic from the physics specification and to plan the order in which you would teach that topic. You don't have to plan out a full teaching plan for several weeks' work, but just really, what would you start with? What would you go on to? What order would you go into the topic? How would you? So you can choose any of the topics you like within physics, or even a part of the topic. You don't have to look at a whole section. But what I'm interested in, how you decide what order to teach the topic. I'm going to stay silent for a couple of minutes while you give that some thought. You don't have to put in the chat the whole content. What you could just do is put like 3 titles. So I'd, if I'm doing waves, I might start with sound waves and go on to light waves and then go on to refraction and diffraction and so on. So, let's just say the order in which you would teach the parts of that topic. And if you've got space, why you would choose that order. Why would you start with the thing you're going to start with? Okay, first one, Nahalo said current electricity, start with current, relation between charge and current, voltage, resistance, circuits, series and parallel. So thank you. Great. It's a very good answer, and thank you for laying it out like that. Okay, some people are starting with parts of topics and see that MTAS, no, sorry, Pike started, PKPK started with the units in use. Yeah, all good choices. I have to say, and thank you for contributions towards this, there isn't a single right answer to this. The answer depends on your students and what you know about your students. Obviously, you will know your students. How well you know them might depend on their background. If you've just picked up students you haven't met before at the start of the GCSE course, there's a little bit obviously of catching up to do. If you taught them in their Key Stage 3 or earlier courses before GCSE, you have a very good knowledge of what they already know. But in either case, it helps to go, I think, from what they already know and build upon that. And sometimes it can be really useful to start the teaching of a topic with a quick brainstorm or whip round or getting students to give some feedback on what they already know about that topic. Because for almost every topic here, it won't be the first time they've met the concept. We have this idea of a spiral curriculum, don't we, where students might meet electricity in year 8 and again in year 10, and if they're doing A level, again in year 12, and each time they're tackling it at a slightly higher level, a little bit like a spiral staircase, where each time you go around the spiral, you come back to the same windows, so you're looking at the same view, but you're higher up. And that's the idea of the sort of spiral curriculum. And it's well worth checking what students have understood and remembered from previously, whether or not you taught it, but how well they've understood and remembered it, and also what the misunderstandings are and what misconceptions students have. And so the right place to start the topic is not necessarily going to be the same in every different school. It will depend on where your students happen to be and what they already know about that topic area. The point I really want to make is that the best way to teach it, the best order to teach, is not necessarily the way in which it's laid out in the specification. It's not laid out in the specification in a way which is intended to be the way you must present the subject. Just because the points are laid out, you need to cover all of them, but the order in which you cover them is very much a teaching and learning decision for you to make as a teacher. And that's about knowledge of how your students already understand some parts of the topic. And obviously some parts of a topic follow others very well, because you need to understand something before they go on to understand something else. I think somebody else said, yeah, Nahala said, without the basic understanding, students find it difficult to comprehend how circuits work. Absolutely agree. So there's some things where you need to learn something before you go on to build upon that. But there are other parts where it's kind of free choice. You know, you could take it in either order. And that is very much, I think, a base of making a decision about how your students are learning best and what they already know. Some people say, in answer to this question, I would simply follow the specification. Sometimes that will work, but it's not always the best order. You don't have to follow it that way. And sometimes people will say, I'll follow it in the way that the textbook that I'm using, whether that's a Pearson textbook or a different textbook. Once again, that's not necessarily the best way for your students to learn that topic. I'm saying it's worth having a thoughts and conversation about which is the best way to deliver the topic for your group of students. And that, of course, may even change for your own teaching from year to year. One group may have particularly understood a topic to a certain level. Their younger brothers and sisters the following year, very different story. So it's well worth being a decision. As I always like to start a new topic with a quick recap, because it gets students back into thinking about that area of what they already know and what they misunderstand. And that might be oral, people just sharing, brainstorming ideas that they already have, perhaps doing some sort of web diagram where they say how the different ideas link. They're all good ways of getting back to students thinking about the topic you're about to start on, but giving you valuable information about what they know and what they thought they know, but actually misunderstood. And it's a really good way to sort of start a topic. Okay, thank you. Mentioned practical skills earlier on, how to prepare students in practical skills. This from the specification, the best way to develop experimental skills is to embed practical investigations in teaching or theory. The development of knowledge and experimental skills can then happen together, leading to secure acquisition of both knowledge and skills. I have spoken to colleagues sometimes who have said, okay, in my school, we get a double lesson on Monday afternoon and then get 3 singles through the rest of the week, one on Tuesday, one on Thursday, one on Friday or whatever. And because we get the double lesson on Monday afternoon, that's when we do the practicals. And so I work through all the practicals I'm going to do on Monday afternoon, irrespective of what theory they're covering on Tuesday, Thursday and Friday. Understand the reasoning for that, but it's not a good teaching and learning idea in my experience. And it does suggest in the specification the best way to develop the skills is to embed them in the teaching or theory. So in other words, they're doing an investigation in magnetism at the same time that they're learning the content. Indeed, doing the investigation is part of the learning of the content of that topic. So it's well worth meshing the two together. And practicals don't all have to be a double lesson a lot long, of course. They don't have to be set up for an hour and a half, whatever the timing is within your centre. They can be short practicals, mini practicals, demonstrations, but it makes good teaching and learning sense for the practicals to be embedded within the time when students are learning those knowledge and understanding of that content. The second point on the screen here, our practical investigations are embedded within section 2, physics content, as specification points in italics, as I indicated earlier. The skills developed through these and other practicals will be assessed through written examinations. There are also practical activities in the appendix. One of the things I do as a trainer in science for Pearson is to produce sessions where we present feedback or what's the word I'm looking for? A condensed version, that's the word I'm looking for, a condensed version of the feedback from the examiners' reports. Every time there's a series of exams, examiners produce examiners' reports saying how students did, which questions they did well, which questions they found difficult, and gives examples of those. And every year in those examiner reports, they will point to the fact that it's really clear when you look at students' work in exams which students have had a restricted diet of practical experiments. Some haven't done enough, some haven't even done all the core practicals, which is a real handicap, but they do point out that students tend to understand and answer many of the questions better if they've had a rich and varied experience of different types of practical experimental experience, going beyond just the core practicals. If they just do the core practicals, they will be able to do a certain amount well, but they suggest that students demonstrating the quality of answers to questions, particularly in things like electrical circuits and energy and forces and so on, if they've had lots of hands-on experience of how those things work in practice. So there is a definite link between students having a rich and varied practical experimental experience and how well they do in the exams, according to the examiner reports. It comes up every single year, so it's clearly an ongoing issue. Here's an example screenshot of part of the specification content. Again, as we used earlier, magnetism. And it shows how the practical investigation, here at 6.6, is identified in italics within the content. A list of the areas which students might be tested on in the assessment of practical skills. Okay, it's quite a dense slide. The point that I'm making is that students may be tested on a wide range of aspects of experimental skills, and it'd be important for teachers to include within their planning lots of time and activities to develop these skills. It's an area which is sadly, as I just hinted, often downplayed in favour of covering all of the content. It's not unusual to hear science teachers saying, I wish I could spend more time doing practical, but there's so much content to cover, we don't get round to it. What I'm trying to emphasise is not to give practical skills the time they deserve would be a costly error in terms of students' ability to achieve well in the exam. This is directly from the practical skills part of the specification, and as you can see on the slide, in the assessment of experimental skills, students may be tested on their ability to do all of that list of things: solve problems set in a practical context, apply scientific knowledge and understanding in questions with a practical context, devise and plan investigations using scientific knowledge and understanding when selecting appropriate techniques. And that devising investigations is a skill that, again, from the examiner's report, students can find quite challenging. They sometimes understand what they've done in a practical, but struggle to be able to apply that learning to devise a different experiment to test something similar but different. You know, if the variable they're changing changes, for example, they find it hard to apply learning in one context to a different situation. To demonstrate or describe appropriate experimental and investigative methods, including safe and skillful practical techniques. To make observations and measurements with appropriate precision, record these methodically and present them in appropriate ways. To identify independent, dependent and control variables. Use scientific knowledge and understanding to analyse and interpret data, to draw conclusions from experimental activities that are consistent with the evidence, to communicate the findings from experimental activities using appropriate technical language, relevant calculations and graphs. And I will say, just on that point, that students are much more likely to be able to communicate the findings in written form if they first of all do it orally. So getting students to share the results of their experiment and talk about what happened in their experiment before they try to write it down is hugely beneficial in terms of developing the language skills they need to explain using the correct scientific terminology. If they can say it in words, they're much more likely to be able to write it. That's particularly true, of course, for students who might not be working in their first language, but it's true for all students. If they can say it and share those findings orally and answer questions, they're much more likely to be able to describe it accurately and logically and clearly in writing. To be able to assess the reliability of an experimental activity, to be able to evaluate data and methods taking into account that affect accuracy and validity. So quite a lot of skills that students may be tested on. Of course, they don't have to focus on every one of those skills in every single practical they do, but it does mean we as teachers need to keep a sort of checklist either in our head or on a piece of paper of which skills we have covered, so that throughout the course, students have learned and practiced some of these skills to be able to tackle them within an exam over the course of the time they've been learning the physics. What our examiners have noticed, I mentioned that after every block of exams, examiners produce a report on how students did, and these are sentences taken directly from those examiners' reports on this specification. Most students were able to recall the equations, and usually they handled the related calculations well. Successful candidates were competent in performing quantitative work, could recall relevant formulae, and rearrange these formulae to obtain the correct answer. It's fair to say that most physics students are often better at answering mathematical questions than they are at answering written type questions, wordy questions. Their math skills tend to be at least up to the quality of their physics learning. So they tend to be able to tackle maths questions at least as well as you would expect a student of that ability in science to be able to. Students who gave the best practical descriptions showed evidence of undertaking all the required practicals themselves and could produce detailed, coherent methods whilst recalling the relevant results of these experiments. Less successful candidates had limited experience or could not recall information from the required practical tasks. They also overlooked the importance of the command words being used. Successful candidates could recall facts whilst applying their understanding to new and complex situations, and responses to the longer questions showed that the less able students tend to struggle when assembling a logical description. Just briefly before I move on to the next section, what do you think are the implications for teaching and learning that arise from that feedback? Are there any things that we need to adjust in the way we arrange our teaching practice with students arising from what examiners have noticed from how students doing it? I'll go back to that page so you can see it, but that's the question I'm asking you to think about and perhaps put any comments in the chat. So, what are the implications for teaching and learning arising from the feedback from the examiner's reports? And this is the feedback that we're talking about. Just looking at Hassan's question, are all practical-based questions tested through written exams, or are there some where the student has to actually conduct a practical in a lab? No, in this specification, the first option is exactly true. The practical-based questions are all tested through written exams. Many years ago, there used to be practical exams, and I loved them as a physics teacher. But I think it may have been expense or difficulty in getting them coherent from one school to another. But no, the practical exams have disappeared. They were all tested, certainly in the specification, through written exams. Absolutely agree with you, Hassan. Sadly, it doesn't happen in the exam anymore, or that particular part of the magic. Breaks come in. Practicals and experiments in lessons need to go beyond the required ones. 100%. I totally agree. Students definitely learn. I mean, it's also a big motivating factor. Many students are motivated and more engaged and therefore concentrating more when they're doing experimental work than they are in some theory lessons. I don't think we should always just cave in. We've all had the classes who said, "Oh, sir, can't we do a practical today?" or whatever. And that's not always the right answer. But absolutely, it's motivating. But also, students, I think, can learn so much when they see it happening and get a feel for how it happens. If they see the concrete first and then go on to learn the abstract afterwards, it's often embedded much more clearly. Students need to practice writing logical and different arguments and not just driving maths problems. Absolutely right. It's very easy sometimes when we're setting lists of problems to focus on the maths examples. And sadly, too many textbooks do a lot of that, I think. And as I say, students actually do quite well at maths, but that may be a credit to our maths colleagues teaching them as well. But also, let's say that we teach the maths part of science very well, but they tend to do better in maths questions than they do in the written ones. So they do need to practice writing logical arguments. And I have to say, one way of doing that, I'm a big fan of it, but getting students to explain their logical argument to other people orally. To start with, they hate doing it because it's quite nerve-wracking standing up and speaking to other people. But when you're explaining your argument to others, if it's not in a logical order, that nobody can follow it. So in order for it to make sense, you get used to the idea of putting things in a logical sequence, and that tends to improve the way in which they then tackle a written example of that. So practicing logical sequences is a really important skill. Students are more aware for do's and don'ts due to hand-on experience. I mentioned earlier on about safety aspects, and the thing that examiners regularly say is that students are too general. When they're asked, how could you make this experiment more safe? Sometimes they'll just give a general safety thing like wear safety goggles or wear a white coat or something like that. Whereas what they're really saying is, what are the dangers specific to this experiment? And what would you do to mitigate that or to make it more safe? And students who've had more practical experience are more able to picture that in their head, so they can think, what's the experiment? Oh, here's the danger. We're stretching wires, so this may, there's a possibility that the wire might snap, so we need to wear some eye protection or perhaps gloves to stop ourselves being cut by, and these sorts of things. Students who are more familiar with it are more likely to be able to picture what are the real relevant safety issues, and so be more specific to the question that's being asked. I like to go through specifications, get technicians to recreate the more unusual and complex situations shown in experiments. Yeah, it can, not every experiment has to be done by every student. Sometimes it can be really useful, a bit like you're suggesting there, even to get different groups of students to do different versions of the experiment, and then other students move around in a sort of circus form to see, so each student presents what they've done and what was different. So you can actually get through quite a lot of practical work in a shorter time by every student having done a practical, but not all done the same one. And they also benefit from when they feedback their results to the other groups, because it develops not just their practical skills, but also their presentation and logical presentation skills, being able to present a logical sequence. And having spoken about what the difficulties were and how they solved them in their practical, they're much more likely to remember them for an exam and be able to be aware of what the sort of practical issues are. What I've seen, they know the science, but they'd like practice to apply them in writing. Absolutely. And as I say, you can get through a lot of that quickly by them doing it orally. If you get students to present even in small groups to each other, which is a bit less threatening than presenting to the whole class, talking through the practical is a really good precursor to writing it. And sometimes, on some occasions, they don't have to go on to write it. If they're able to talk through the issue, it works really well. There's a piece of research work done by a computing company where computer engineers were given, in effect, a small fluffy dog or something, just a model, a toy, and they talked through their ideas and their suggestions with this inanimate object, and they found that that improved their problem solving. Simply putting it in words, even though the thing that they were speaking to couldn't understand, actually improved the logic. And so, this was sort of a tool. They had this fluffy toy or whatever it was that they would explain their reasoning to, and putting it in words helped it become a better solution. So, you know, getting students to talk through their ideas, whoever to, is a good thing. Increasing practical allows students to imagine what a lot of topics in physics means and see it in daily situations. Absolutely. Mathematical problems are needed, certainly. I'm not suggesting you don't do the maths questions, as they help them in thinking and developing and knowing the origin of the phenomena and how to achieve most develop it. Yeah, wouldn't disagree with any of that, Mohammed. Thank you. Students who've been taught all the practicals and have deep knowledge of the topics are able to answer correctly. There's no getting past that. You're absolutely right. The examiner report gives the teacher an overall viewpoint of those avenues where students have performed well and where students are lacking in practice. It gives a better chance for the teacher to focus on those weak points and ensure that the student feels confident in those areas too. Yeah, I used to think in the early years of my own teaching career, I knew these examiner reports existed, they've always been done, but I used to think they were for somebody else, you know, for the head of department or perhaps for the exams officer. I don't know what I thought they were going to do with them. But the more I've gone through my teaching career, the more I've realised there's gold dust in those exam reports. The examiner reports give real information, not of much benefit to the students who they're talking about because they've done their exam, but for their younger brothers and sisters who are going on to do the exam next year, for us as teachers, it's really good information about where the problems are, which things we're teaching well, in effect, or which things students are learning well, and which things they're not learning so well, and helps us to adjust to make that better the next time around. So the examiner reports, you think, oh, that's going to be quite dry, but it's really important information and good practical information. You know, lots of students got this wrong. This is how you could put it right. There are good, sensible teaching and learning tips in those examiner reports. Well worth looking through. You can download them freely from the website within a few days after the exam results come out themselves. And as I say, really important information for every single physics teacher in there. As a teacher, we need to relate practical with theory and reasoning in a simple way. Now it depends on teaching methodology and on students' previous concepts as well. Try to simplify the concepts as max as possible with logic and reasoning. Yeah, thank you. Thank you. Through practical exercises, students are exposed to the difficulties of understanding the subject matter, which could foster their development of logical thinking and problem solving. I've just joined the training. Anybody help me share previous slides? Yes, I can do that. At the end of the session, Mohammed, just within about an hour of the end of the session, all of the slides will be shared with you. A link will be sent to the email that was used to register on this. It will ask you to complete a short evaluation, which I'd invite you to do, but it will also give you a link both to be able to download the slides and download if you want a recording of the session, so you can go back over anything you missed. So yes, you can get copies of all the previous slides after the end of the session. Okay, let's move on to the next bit. Thank you for that. It's really helpful. Thank you for all those comments. I really appreciate your engagement in that. We've just seen that question. So this one. Topic 8 is astrophysics, and I think if I asked you to say which topics in the specification are you most familiar with and which you're least familiar with, more people would come up with this as a topic which they're less familiar with. Maybe because you haven't taught it before, or more likely because it wasn't in the course you did when you yourself were a student learning physics. It's, you know, a bit more out there. But also, when you have taught anything to do with space, solar system, anything to do with astronomy, there isn't much practical in there. It sounds really exciting, and students think, yeah, great, we're going to do about space, you know, and all young children love space, and they'll remember that when they get to GCSE age. But obviously, for most of us, most of the time, we don't have students during the hours of darkness. They tend to come to school during daylight. So the exciting stuff of, you know, looking through telescopes and so on isn't really available to us for most of our students in normal teaching and learning situations. I've heard people come back to me and say, yeah, we're in a boarding school and we live on the side of a mountain in a dark area, and so we've got a fantastic telescope opportunity, but most people don't have that, we have to accept. So what I'm asking you is, what student learning activities, and I'm talking things like practical activities or active learning activities, might you include when you're teaching astrophysics, space, solar system, the universe, all those sorts of things? So a quick sort of, I will share some resources with you yourself, but I'm asking first of all, what activities have you found useful or do you think will be useful to do when you're teaching the space topic, astrophysics topic? Okay, simulations are good. I agree. You mean like on-screen simulations, pretty much sort of computer simulations of things like the solar system and yeah, I'm guessing. And they can be really good. And there's some really good ones available too. Yeah, yeah, I used to think that. I must admit, documentaries and videos, there was a time, as I said, I've been teaching for 33 years and then doing this job for another 7 or 8. So when I started teaching, dragging the video recorder out was the way to get your class silent and engaged. I thought, great video. But I won't lie to you, that's been diminishing returns over the years. There's so much available on TV, multi-channel, satellite TV, on YouTube and so on. Students see screens again and again. It's not the exciting activity that it once was for students. So it has its place, don't get me wrong. There are things that are worth showing, but you can't guarantee that just because it's on a video, students will be excited by it, is what there was a time, as I say, where it was the treat at the end of term and students were agog, but they're not agog at video anymore. People will often watch television at home with one eye on their mobile phone and scrolling through their social media and doing something else. That it doesn't grab attention in the way that it once did, in my experience. Circular motion using excuse me, using a mass to a thread, flashlight, two balls to represent the moon phase. Yeah, the whole bit of having a light bulb and showing the shadows on a white ball as you move around all that sort of stuff is brilliant, I think. So simulating things like the phases of the moon, the seasons can all be done really usefully with a bit of imagination and a light and a globe or a white reflective ball and so on in a dark room. And that's all good stuff. It really is. And similarly, though it takes a bit of setting up, modeling the solar system by getting students to represent the planets and sending them out to distances to walk in circles on the school field or the playground or whatever can be really useful. So students get an idea of how, because we are on the Earth, which is itself orbiting the sun, when we look at other planets, we're not seeing them move in a circle. They're moving relative to us in a different sort of shape. And it explains why some of the planets close to us, like Mars, seem to go backwards at some stages because we're in effect overtaking them. It always amazes me how the early astronomers, we're talking back in ancient Greeks and so on, but also people through the early modern period, how they were able to work out how the planets were moving. Because just seeing the dots moving in space and saying that must mean we are. I'm just in awe of those early scientists. It's incredible. And you can model all of that, I think, on a playground with students going out to the distances. Simulations, good. Effect of gravity, difference in gravity on Sun and other planets videos. Yep, good. Also, some videos, isn't there, of the space of the moon landings, and there's a famous one of one of the 12 people who's walked on the moon dropping a hammer and a feather on the surface of the moon, and the fact they both fall together because there's no air resistance and so on. So all good stuff. I do an experiment by heating an iron rod and record its heating by a camera, then make a slow motion for the heating, relate the mechanism changing colour by changing temperature. Yeah, for different colours of stars. Really good. Why does it keep kicking you out? I have no idea, Fangchen. I'm afraid that's a question for your Internet service provider, I think, rather than us. I don't think the Zoom is the thing that's kicking you out. But apologies, as I say, you may have to make use of the download of the recording afterwards. Simulation website called PhET. You're absolutely right. That's from one of the American universities, isn't it? The physics, is it Colorado University that do the PhET scheme? Yeah, there's some really good websites available for, and I'll mention one to you in a moment. It's surprising to discover, and you're absolutely right, but they don't, that students don't know how the phases of the moon occur. Month before teaching this topic, ask the students to notice how the moon changes its appearance. Yeah, to get students to sketch what the moon looks like twice a week for a month can be, students are astonished by the fact it changes, because sometimes they don't look at it, they notice, and sometimes it's different, but don't realize there's a pattern to that. And you're absolutely right. It was a time when we all learned that in junior school and would do that sort of thing, but it's a really instructive thing to do. Really good. Solar system and gravitational field. Yeah, there are good experiments within those. Use a swing ball set and slow motion recorder for orbital speed. Yeah, yeah, good. Slow motion videos and the classic test tube mass and thread circulating. Yes, where you pull the string down and it, yeah, good one. Used to have a field trip to an observatory. Yeah, that is really good as a motivator. If there's a local observatory or one that you can get to in sensible time, it can be really, really exciting. For students to be able to see Saturn for themselves it really brings awe and wonder into that. I can remember the first time I saw Saturn through a telescope, and you've seen it so many times in a book, you can't believe it's really there in the sky and you're looking at it. It is quite incredible, and young students can have their life changed by it. Creating a different research task for each group and asking them to present their part, really good. Yeah, I'm a big fan of that, because it not just teaching the research skills, but also the presentation skills. Really, really powerful. Oh, I'm sorry you can't unzip the specifications. I don't know whether that's the one that you've downloaded from the course material, the resources here, or whether you've downloaded it directly from the website. But I suggest you try the other one, as it were, and just see whether that makes that available. Star life cycle diagrams, yeah. Astrophysics quizzes and games, spectroscopy experiments, yeah, that's good. If you've got the equipment to do that, that'd be really good. Physical models of solar systems. Yeah, I think Fine is being absolutely honest there, Fine. Nobody's kicking people out of the meeting. I think that's an issue with the your own internet connection. So to say, you might need to close your computer down and restart it again, thing. I don't think you're being ejected. I'm sure you're not being rejected at this end. Alexander, yes, the training does continue tomorrow, exactly the same time. I think the Zoom link should be sent to you with registration. I don't have that separately. But yes, it's the same time start tomorrow, 9 a.m. UK time, however that translates to your own time zone. Yeah, a good point, Quasi, because yeah, you're right. Specifically, phase of the moon isn't included. No, but I think I was simply asking what activities people have found useful, and sometimes I think it is worth to get the whole picture of the idea of the circular orbit of the orbits, both of planets around stars and moons around planets. I think things like a quick demonstration of phases of the moon can be really useful, because it gets students into the idea of thinking how the whole thing hangs together. So whilst they don't have to remember the different phases, the idea that the moons orbit the planets and the planets orbit the sun and so on is there. So I'm saying it's important information. I think one thing personally that I've always found students struggle with is the massive difference in scale between sizes of the planets and the spaces between them. Because of the way it's drawn in textbooks and on posters, as you know, as physicists, the distances between planets is quite enormous compared to the sizes of the planets themselves. But often to fit it all onto a single poster or a picture in a book, you'll all have seen diagrams where relative position of orbits are shown with planets drawn which are absolutely huge compared to the distance between them, just because the scales are so different. A thing I've found quite useful for getting students used to that scale is a thing which I call a toilet roll solar system. So a standard toilet roll, with with perforations between the sheets. And I say, okay, students, in groups are given a toilet roll, fairly cheap resource, and you say the length of one sheet is 1 astronomical unit. In other words, the distance from the sun to the Earth, average orbit, is one sheet of the toilet paper. Draw on there where all the planets would be. And of course, the inner planets, Mercury and Venus, are both on the first sheet. Earth will be on the first set of perforations from the end. Mars will be about 1.5 sheets after that. But by the time you get to the outer planets, Jupiter, Saturn, Neptune, they are many, many sheets. We're talking about 40 sheets to get out to Uranus and Neptune and so on. So laying it all out across a large desk gives students a real sense of why we can see the local planets, Venus, Mars, Jupiter, Saturn, with the naked eye. But we need impressive astronomical equipment to be able to see the outer planets because of the distances and the relative sizes. It's a really useful way, I think, and it's fairly easy then to blue tack or sellotape that up to the wall and refer back to it when you're talking about the distances. If you've got intelligent groups, you can, when they've done their solar system, you can say, okay, how many sheets would we need to get to the first star on this scale? And to save you working it out, we're not talking a number of sheets on the same roll. We're talking many, many toilet rolls further on. You don't have to model that out, but if they work it out by scale, yeah. Is there a resource hub where we have access to books, notes, and resources on practical-based questions? I'm glad you asked that, because, just moving on to the next slide, there are a number of websites that contain downloadable resources. Other people as well recognise the fact that this is an area which is difficult to do in practical terms, and so there are quite a few good resources for this and other topics. There's within this course, and you can download it from the same website under teaching materials from the Pearson website itself in the physics page. Look under teaching resources and you can get this, the Astrophysics Guide, which has within it a wealth of various ideas that you can use for practical and teaching and learning activities. But there are other websites, not directly linked to physics, but which produce excellent resources. There's the Association for Astronomy Education, the AAE. NASA produce fantastic video-based and other resources, and you can download those freely. The Royal Association of for Space, is that Royal Astronomical Society, Royal Astronomical Society, that's right, the RAS. I'd also recommend the Institute of Physics, IOP. The IOP do some superb practical resources and ideas for practical activities, not just in this topic, but in all physics topics. If you go to www.iop.org, they have what they call a Spark project, and it produces school-based science practical resources and ideas across all teaching stages, from primary right up to advanced level and beyond. And there's some really, really good resources within there. So all worth exploring. But as I said, the topic guide itself, so do look within the teaching and learning resources on the Pearson website and see what you can find there. I'm afraid, Lakshmi, I don't have direct access to be able to do anything about the admin of the certificates. That's not within my purview. I would suggest you contact either the science advisor, as I say, I'll give her a link later on, or go back to where you registered and speak and email them. I'm sure it will be possible, but it's not possible for me to do it, is what I'm saying. How do I make sure I cover all the content? This is just an introduction to a couple of slides with a list of areas to be considered in ensuring full coverage of the content. To make sure you covered all the content, you're going to need to consider the specification itself, lesson plans, schemes of work, and year planners. Obviously, lesson plans themselves, but there's nothing more frustrating than getting to the end of the second term or the fifth term of a 2-year course and realizing you've still got more than a quarter of the course to cover. You know, you've covered the early topics to too much detail or taking too much time and run out of time. So you do have to plan, obviously, how you're going to cover, which topics you're going to cover throughout the whole course, as well as what you're going to teach over the next week or two. I'm sure this is not news to you, but it's really, as I said, this course is really for people who are new to the specification, and it's really easy to get tripped up, even as an experienced teacher, when you're teaching a new course. It's easy to get swamped into over covering the early topics and then having to rush the later topics. So there are a number of resources that are available to try and help with this. This is a screenshot of the first part of a 2-year course planner, which is included in the Getting Starting guide, which I just mentioned on the previous page. Again, you can download the Getting Started guide and other teaching and learning resources from the main Pearson Physics subject page. The course plan is also available as a Word document at the same online location, so it makes it easy for you to edit and fit to your own needs. So please don't think that the way the topics are laid out on this example course planner are the way you have to teach them, but they're all either in an Excel or a Word document, so it's easily editable and you can rearrange them in the order that you want to cover them. But you'll notice that it says here the hours per topic suggested and what lesson content is in there. And so you can mix and match them both to your own. You need to adjust them to fit your own school's timetable and the number of contact hours that you have per week, but also for things like whether your school delivers the GCSE over 2 years or 3 years or some other time period. If you're teaching it as a linear course, there's flexibility about which order the topics are taught in. So as I say, the order of topics in the spec and in this course planner are not intended to suggest that this is the only or the best order in which to deliver the content. It's fairly easy to cut and paste them and arrange them in the order that you want to use. Just a quick question then. How do you plan your own lessons in physics? Do you, for example, have a common lesson structure, perhaps set down by the school or set down by your department as a starting point? Or do you have your own lesson structure, a sort of template that you use for planning individual lessons? Or do you have a blank sheet of paper? Or do you do, what they call doorknob planning, where just as you're turning the knob to go into the classroom, you think, what am I going to do this lesson? I hope not, but what method do you use to plan your lessons in physics? And are there any ways that you might need to adapt this to deliver the specification? I'll give it a few moments for you to put your suggestions in the chat. Sultan, I'm not avoiding your question, but I'm not in a position to be able to recommend specific textbooks or to say, I'm afraid that's a decision. It's a discussion you could have with the science subject advisor, and she'd be more free to comment than I can, but I'm specifically forbidden from having conversations with you about which would be a good textbook to use and which wouldn't. So I can't answer that question, I'm afraid. I'm not familiar with that specific book, so I'm not entirely avoiding the question, but I can't really say this book, not that book. The link that I gave you much earlier, so higher up the chat, if you scroll back up through the chat, I gave you a link to where you can download online the specification. That's also the page where you can download the other resources that I'm referring to. The specification was in a thing called specification and sample assessment materials, but underneath there are also teaching and learning resources, past exam papers, and each of those links will show you to the other resources mentioned, like the astrophysics book, like the scheme of learning and the scheme of work and model lesson plans and so on. So all of those are within that same page. Just to mention about that physics page, I mentioned right at the beginning the 2 different routes that Pearson deliver, UK GCSEs and international GCSEs. up at the top right-hand side of the title page of the home page, there's a little tab where you can click UK or international. Make sure you choose the correct one, that you click on international, and then that will give you the resources, past papers, and all those sorts of things relevant to the specification we're talking about. I, over the years, I kind of developed a lesson plan, which isn't, one that I sort of share with other people. It was just specifically for me. But I found that more useful than just starting with a blank sheet of paper, because you can, it helps you remember to cover all the bases during the lessons. It just reminds me, oh, have I included a sort of practicing activity? Have I included some practical element? Have I included a link to where this particular topic fits into the wider scheme of work, so to sort of create the picture? So having a simple template for myself, I found really useful in terms of reminding me what elements I need to include within a good lesson. Otherwise, it's very easy, if you're just planning them on blank sheets of paper, in my experience, to miss some things and regularly miss them. If I'm teaching a practical but not thinking what are students learning during this experiment, if I focus too much on what they're doing rather than what they're learning, it's easy to sort of make that mistake again and again. So I find a sort of template is useful. And some departments have a sort of departmental template for exactly that reason, and they can be really good and well worth using. Some schools have a template for the same reason, and that will vary from school to school. But if your school doesn't specify anything, I'm just saying in my personal experience, I find it useful to produce something like that for myself. And you can vary from it, but at least you're asking the question each time I plan, do I need to include some element of demonstration in this one? Do I need to include an opportunity for students to practice the learning the new learning, and so on? Thank you for that. That's really helpful. Okay, just a brief look through then. This is just really sharing ideas, some of which you might already be aware of, about support and resources that are available. So a quick skip through some of the resources that are available to you on the Pearson website or through Pearson for teaching this and other Pearson specifications. Okay. In terms of planning, teaching and learning, you can see there's the getting started down the left-hand side, getting started guides, various training events, subject advisor support, as I mentioned Irene a couple of times, community forums, schemes of work, skills mapping, sample assessment materials, examiner reports, as I say, gold dust, exemplar marked responses, and I'll give you more information about those during tomorrow's session. Again, really, really useful activities and information in there. Past papers, of course, Exam Wizard, which I'll mention a bit more about in a moment, mark schemes, Results Plus, I'll mention Results Plus again in a moment, and the Access to Script service, all things which can provide various support, all available through the Pearson website. Large number of resources available on the website itself. So here's a screenshot of the homepage itself for this specification. You can see the download of the specification itself down the top left there, the blue document. But over where the arrow is pointing, the course materials, you can access specification and sample assessments, exam materials. You can see the 124 because it's going back through lots of past papers, mark schemes, teaching and examiner reports are within exam materials. Then in teaching and learning materials, things like the astrophysics book, books about core practicals, and so on and so forth. So lots of resources available through the hyperlinks on this main page. And we're continually adding to this bank of materials, which is why they're downloadable online rather than sent out as printed documents, because anything you print tends to become out of date fairly quickly. So the updates are always available within this website. Quick mention of Results Plus. If you're not already familiar with it, Results Plus is a tool that teachers may find useful, I think find very useful, in analysis of their students and their own teaching performance. Using Results Plus, you can see in-depth data on the performance of candidates within your school or in a class or across the whole school. You can use it to see which questions or specification points students have performed well and poorly in, and use this in choices around revision. So in other words, it means you can download a breakdown of how your students have performed compared to other students across the whole paper, but also question by question or specification point by specification point. In simple terms, it tells you where the bodies are buried. You can see on there, this is an area where students in my school are doing better than students on average in this question. So really, they're understanding this material really well. On the other hand, here's a topic where my students are doing less well than students across. So perhaps I need to adjust how I teach that particular area. So it really tells you, specific to your school or even your classes, where students are doing well, where they're not doing so well. It saves you wasting a lot of time improving the teaching and learning on things which students are already doing well on, and lets you focus that development to your teaching and learning, perhaps with other colleagues in the department, on areas where your students aren't doing so well. So really, really useful information. And that's freely available to any school or any centre that's entering students for any subject in for an Edexcel paper, Pearson paper. Daisy said, where can I find the practical book? I think I've got a link to that somewhere. I think I'm coming up for that tomorrow, so I'll check, but I'll be able to put a link in the chat tomorrow for that. It's on exactly the same page. Sorry, if I go back a slide, 2 slides, on this page here, no, wrong one, my apologies. On this page here, you can see, if you go to this home page where it says under course materials, the practical book is under teaching and learning materials. So if you follow the link on there, you can download the core practicals booklet. Okay, just mentioning the Results Plus, it's a free online service to all Pearson Edexcel centres. It was developed in 2007 when Pearson looked at how it could modernise exam marking, and it brought over what was a marketing technology called ePen from the United States. So students take their exam in the old way. In other words, it's printed on paper and they take it in a paper-based way. But what used to happen in years gone by is that the papers were then bundled up and all sent off to a marker. That doesn't happen now. They're bundled up but sent to a central processing centre and are then scanned in through a series of machines. And it's those electronic copies, digital versions of the students' exam papers, that are sent electronically to examiners. And that means particular questions from the same paper might be sent to different examiners. So one examiner might be marking question 1 and 5, and a different examiner marking question 2 and 6, and so on. So it can be sent depending on their expertise. They're marked on a screen digitally. And crucially, that means there's all that marking data is available, which is coordinated and available to you through the Results Plus system. So it makes a really useful resource that you can literally say, how are students in my class doing on questions linked to the specification point about Doppler effect, for example? And you can print out that resource or immediately access that resource, and it will say your students are doing as well as students on average, or better than, or worse than, with exact percentages and so on. So it gives you immediate feedback on how your students are doing in each part of the paper. Is this how papers are marked for all Edexcel GCSE papers? Yes, is the answer. Yes. And a brief look at Exam Wizard. Exam Wizard is a way to access the past papers, but rather than get at whole papers, to look at question by question. So it's a free tool. Again, it's available free for all teachers who are working within a school, entering any students for any Edexcel subject. It allows you to make quick homework assignments, topic tests, mock exams. The questions are tagged against units and topics and assessment objectives. It uses existing mark schemes for accurate marking. So that to me is the most powerful bit of it. When you say, okay, I'm going to put together a paper with 3 or 4 questions, all based on magnetism, not only do you get past paper exam questions or part questions that are on that topic, it automatically, as you pick out 3 or 4 questions, it puts together the mark scheme in the same order that you've put the questions. So you've got a homework worksheet or a end of topic test worksheet, and it automatically gives you the mark scheme, which are set to the exam levels. So you know that the marks you're giving are what students will get for those questions in a real exam. So it can be really, really useful to put together topic tests, half-term tests, mock tests, or even individual homework worksheets. It uses the examiner reports for insight into those questions, so you can see where the errors or issues arose in those questions earlier. You're absolutely right, Susan. It is amazing. I couldn't believe all that was available freely the first time I used it. It's freely available to you in a school entering students to Edexcel. If you can't access it immediately yourself, the key to what you want is your exams officer, because the exams officer in your school has access to be able to, they can access Exam Wizard, but they can also crucially provide you with a username and a password to be able to access it yourself. So if you find you can't log into it yourself immediately, go to your exams officer in your school, and they will be able to give you access to that Exam Wizard, and that, give you a free login. It really, really powerful for being able to use past paper questions and give you mark schemes that you want. And also mention the access to scripts. At the moment, Pearson's the only exam awarding board awarding this, offering this freely. It means on the day that your students get their results day in August or whenever, you can access your own students' marked scripts. You can see your own students' marked exam papers free of charge. It's available free for all qualifications, and you can access it through Edexcel online. The scripts don't have examiner annotation on them, but it does have the marks, question and part question by part question. So we've all been in that situation where you go in on exam results day and one of your students comes up and says, I've got a D, or a whatever, a 4, a 3, and you think they should have done better than that. Before you automatically send off for a remark, you can have a look at their paper and see whether they just had a nightmare day and just threw it because of whatever reason, or do you think, I think that could have been marked a bit more fairly, I think it's worth asking for a remark. So it allows you to see the student's paper, but also it's a really useful teaching and learning resource. I find that there's few things more powerful when you're looking at past paper questions with the next year's cohort of students to say, let's have a look at 2 or 3 examples of how students who were sat in your chair last year tackled this question. And let's have a look at why this is a good answer and why this isn't such a good answer. And most students are very happy for you to use their past papers as long as you make them anonymous. You don't want to say so-and-so and give the name of the student whose answer this is. But if you say anonymous, here's one of our students from last year who tackled this question, it's a really useful teaching and learning resource, because students can see, particularly in those questions that we found students find really difficult, the longer written questions where students find it hard to express themselves clearly. Students can see what makes this a really good answer, or this answer is perhaps a little bit average, and it's a really useful resource. As I say, they're available from results day onwards. You can download them as PDFs, or you can print them out and put them into PowerPoint, use them as you wish. Technically, when a student has completed an exam paper, it's their property. So you should ask your students permission to do that. But as I say, in my experience, students don't turn down permission. What they want to know is that you've taken their name off them, but you use them anonymously. ATS is perhaps only accessible to school authorities, or even it's only accessible to teachers teaching in a centre with who are entering students for Edexcel. So yes. So as an individual teacher, same as I mentioned earlier, if you can't access it immediately yourself, talk to your exams officer and they can give you the login. I absolutely agree. There was a time when we thought that, but the accountability is brilliant. I think the reason, sorry, I'm answering Susan's question here, where you said very few exam boards would allow such accountability and transparency. I think the reason is that it stops a lot of speculative requests for remarks. I think they found that sometimes schools would submit half their papers for remarks, and obviously the cost involved in that, but you know, when the student had just had a bad day, and it cuts down on the speculative ones. It means people, you can still request a remark, but it means you tend only to do it for students where you think there's a real chance of them being up to grade because you've looked at their paper. So I think it cut down work for the exam board on marking speculative remarks, as it were. But yes, I think it's a really powerful thing, and as I say, it's accessible to everyone. So you know, please do use it. Thoroughly recommend it. Feels like you're cheating almost, but you're really not. It's a really useful resource. I'll just mention additional paid for resources, Active Learn, the Active Books and Teaching Hubs, and we can say a bit more about them. You can look at more about what's available on the Pearson booklets. Pearson publish resources, as well as being an exam board. Pearson obviously is a publishing company, so there are textbooks and teachers' books for each of the specifications that are offered. I have to say, and it's you don't have to use Pearson textbooks in order to teach Pearson specifications. We believe they're good ones, but if you have resources that you've already used and which you're happy with, if you've changed from a different specification, you've got a textbook you really like, as long as you check that they cover the same content at the correct level, you can continue to use them. Okay, so these books are specially developed for international learners with appropriate international content. They're on the recognised 9-to-1 grading scale, so learners achieve their full potential and make more informed decisions about options for progression. Each student book provides 3 years of access to the active book, the digital version of the student book. So there's a code within the book when you buy it, and students can access the digital version within that, which gives additional resources such as online learning and additional questions and things like that, and simulations, videos and things. Biology, chemistry and physics are all supported by the brand new Teaching Hubs platform, which again is accessible online. And the embedded transferable skills which are needed for progression to higher education and employment are all signposted so that students can understand and engage with the skills. If you want to know more about the resources that are available, you can follow the link that's at the bottom there and look at what's available in their catalogue of books and see what's within them. Okay, I'm not selling the textbooks, but you can go to the website, which is. I mentioned the teaching hubs. The new teaching hubs provide fully comprehensive planning and front of class guidance, along with exam preparation resources and CPD support to help you deliver the International GCSE lessons to a high standard, whether you're a specialist or non-specialist teacher. So hopefully spend less time with planning, with schemes of work that break the international specifications into hour-long sessions with detailed lesson plans, as well as in-depth teacher guidance. There's a wealth of front of class resources, so PowerPoint presentations, things like that, linked from the lesson plans, which include interactive exercises, animations and videos, plus an overview page containing all the top level information about the lesson, as well as links to the textbook. They have lesson plans giving partially scripted instructions for communicating learning points and correcting misconceptions, written by a team of expert subject authors. These new online teaching hubs provide complete coverage of the guided teaching hours, and they can be used for live teaching as well as advanced preparation, saving you planning time so you can spend more time teaching. These are paid for additional resources, so it's worth looking, contacting and seeing if you're interested, if you're in your school using these resources. And in order to do any of that, strongly recommend contact with your subject advisor. This is Irene. Irene, whose name has been spelt wrong on this slide. It's actually I-R-I-N-E, but Irene is the dedicated subject advisor for science, and you can contact her directly through the what's the word? It's the online form, which is at the first link there, qualifications.pearson.com/contact us, or you can email her directly via teachingscience@pearson.com. Irene has been the science advisor for several years, and in my experience, is an absolute wealth of knowledge about this and the other science specifications that are offered, both UK and international. If she doesn't know the answer herself, and in my experience, she usually does, but if she doesn't, she'll direct your question to someone within the organisation that will, and will get back to you. So really, really good. Another facility that Irene offers is you can subscribe to an email update service. So you contact her through the email address at the bottom there, and she will send you email updates if anything changes within the specification for either your area of the world or within your specification. Obviously, the specification content itself isn't changing within the lifetime of the specification, but things can change. For example, during the pandemic period, when different areas of the world had different regulations and changes to exam and submission dates and exam arrangements and so on, this was a real lifeline. You know, the email update would mean you didn't have to keep scouring the website to see if there'd been any changes. You would get email updates. It's not used to send you adverts and promotions, but just literally updates which are relevant to your teaching and learning to this. So strongly recommend sending her an email, which you can do as an individual teacher or as a school, to say, can you subscribe me to the free email update service, and I can update you on what's available. What is the difference between a student who appears for Edexcel IGCSE 9 to 1 and Edexcel IGCSE Combined Sciences? No difference at all, really. There's the IGCSE, the Combined Sciences offers double GCSE, double award, so 2 GCSEs, which incorporates physics, chemistry and biology, and counts as a double grade. So you get a double grade for that, counting as 2 full GCSEs. Students who enter the individual sciences, if they enter all 3, will get 3 separate grades, 1 for physics, 1 for chemistry, 1 for biology. But I'm not sure if that's answering the question that you're asking, really. Is physics more complicated in combined science? No, I would say the opposite is true. It's the same content, except there's additional content for the physics single science. So within the specification, it's a common specification for both. If you look through the physics specification, you'll see that the physics component of the combined science is all of the content which is in ordinary print. The specification points which are in bold type and with a capital letter P next to the point are only in the single physics. So students doing separate sciences will have more content to cover than students doing physics as part of the combined science. In terms of which is more recognised, no right answer to that. Both are equally recognised. So just be aware that centres of advanced education, so sixth form centres, for example, and universities, the combined science counts as 2 GCSEs. If you do all 3 separate sciences, it counts as 3 GCSEs. Used to be the case that some sixth forms would say, we need you to have done separate sciences to go on to do A-level here. That's not generally the case anymore. They simply need above a certain grade for whatever their entrance requirements are. But it's worth contacting your local sixth form providers, if that's not provided within your own school, just to check what their entry requirements are, so you're not misadvising students. But in my experience, certainly within the UK now, sixth form centres and universities accept the combined sciences as 2 good GCSEs, and then they're looking at the advanced level grades and so on. They'll also look at the grades, obviously, in maths and things like that. But there isn't a sort of value difference. There's a difference in the content covered. So as I say, it's worth checking with your local further education and higher education providers to see what they're talking about. Okay, done quite a lot now. We've come to the end of the formal presentation for this morning session. I do hope you're able to join us again tomorrow, 9 o'clock UK time, for the one where we're looking at, particularly at the assessment and how the questions and how students tackle different types of question and what the marking scheme's like. And we will look more at exemplars and a little bit of an exam technique. But thank you very much for your involvement today. I invite you to share in the chat box one thing that we've talked about that you'd like to try out or do as soon as you return to your classroom or department, but that's entirely up to you. I would invite you, as I say, when the link is sent to you for the evaluation within the next hour or so, it should only take you less than 30 seconds, but it does help us to see whether we're meeting delegates' needs with these sessions. So if you do have time to do that, I'd appreciate it. Also, as I say, if you're able to share in the chat box one thing you'd like to do. We've got a few minutes left before we run out of time. So as I say, we're finished. You're welcome to log off and leave the session now if you wish. But if you do have any follow-up questions, I will stay online for a few minutes and just ask if there are any questions. So if you don't have any questions, as I say, thank you very much for joining us. Hope to see you again tomorrow. If you have no questions, then enjoy the rest of your day. Hopefully see you again tomorrow. Thank you very much. Oh, good ideas. Find a simulation for astrophysics. Yeah, some excellent ones available. Find out more about Exam Plus. Yeah, and Results Plus, Exam Wizard, sorry, and Results Plus. Yeah, really, really good. Thank you all very much too. Thank you for your thank yous.